Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0182, refers to a low-voltage condition in the fuel temperature sensor circuit for the Honda Civic models from 2006 to 2011. This specific issue indicates that the voltage reading from the fuel temperature sensor is either very low, which could signal a malfunction or disconnect in the sensor circuit, or the temperature reading is exceedingly high, which is abnormal for vehicle operation. The fuel temperature sensor plays a crucial role in monitoring the fuel temperature to ensure optimal engine performance and fuel efficiency. It is typically located within the fuel tank or in the vicinity of the fuel pump assembly. Accurate readings from this sensor are essential for the engine control module, ECM, to adjust fuel delivery and ignition timing appropriately. If unresolved, this DTC could lead to poor engine performance, increased emissions, or fuel system inefficiency. In the following slides, we will explore how to troubleshoot this DTC methodically. The fuel temperature sensor is a vital component in managing engine performance. It measures the temperature of the fuel, providing data to the engine control module, ECM, to optimize fuel delivery and combustion processes. The sensor is primarily located within the fuel tank, often installed alongside or integrated with the fuel pump. Its role in the vehicle is crucial, as incorrect temperature readings can affect fuel system pressures and engine tuning, potentially resulting in performance issues such as hesitation, stalling, or decreased fuel efficiency. The relationship between sensor output and the ECM is fundamental, because when the sensor detects abnormal temperatures or low voltage conditions, it can trigger diagnostic trouble codes. Thus, accurate monitoring of the fuel temperature is essential for maintaining optimal engine health and performance. Several issues could lead to a DTC P0182 being thrown in your Honda Civic. First, the most common cause is a faulty fuel temperature sensor itself, which may provide inaccurate readings due to internal failure. Secondly, wiring issues can result from frayed wires or insulation degradation, leading to intermittent connections or shorts, which can affect sensor performance. Furthermore, poor electrical connections at the fuel temperature sensor or at the engine control module, ECM, terminals can similarly create reading inaccuracies. Each of these potential culprits must be thoroughly investigated to pinpoint the root cause of the low voltage condition. Understanding these causes is essential for informed troubleshooting and effective resolution of the issue. Drivers may observe several symptoms if DTC P0182 is present in the vehicle. The most noticeable symptom is the illumination of the check engine light on the dashboard, which serves as an alert from the vehicle's onboard diagnostic system. Additionally, erratic engine performance can occur, characterized by performance issues such as poor acceleration, misfires, or stalling, attributed to incorrect fuel levels being delivered to the engine. Furthermore, the vehicle may exhibit increased emissions, which can lead to failing emission tests and impact environmental conditions. As these symptoms can escalate, it is crucial to address the DTC promptly to prevent further damage and maintain the vehicle's operational integrity. The first step in troubleshooting DTC P0182 involves turning the ignition switch to the on position, denoted by the II symbol. Once the ignition is activated, utilize the Honda Diagnostic System, HDS, to access the data list for the fuel temperature sensor. Inspect the temperature reading reported by the HDS. It should be around 356 degrees Fahrenheit, 180 degrees Celsius or more, or alternatively, equal to or less than 0.08 volts. These thresholds are crucial for assessing if the sensor is functioning correctly. If the reading meets either of these abnormal conditions, you will proceed to the next troubleshooting step. If not, it indicates an intermittent failure, leading to a suggestion of checking for poor connections or loose terminals at both the fuel temperature sensor and the ECM. In the second step of troubleshooting, turn the ignition switch to the lock position indicated by the 0 symbol. Next, disconnect the fuel temperature sensor from its 2P connector, which is essential for isolating the sensor's operation. After disconnecting, turn the ignition switch back to the on position, 2, without reconnecting the sensor. Once again, check the data list through the HDS for the fuel temperature sensor reading. Similar to the first step, the reading should be approximately 356 degrees Fahrenheit, 180 degrees Celsius, or less than or equal to 0.08 volts. If you observe this abnormal condition, it will guide you to the next troubleshooting step. However, if the reading is within normal limits, it may indicate that there are intermittent faults, prompting you to move on to other checks. For the third step, once again, turn the ignition switch to the lock position. This prepares the system for further testing. Next, utilize the Honda Diagnostic System, HDS, to jump the SCS line, necessary for diagnosing system circuits. Following this, disconnect the PCM, Powertrain Control Module Connector B, which consists of 44 pins. This setup allows you to check the wiring between the fuel temperature sensor and the ECM. Proper access to these components is essential to ensure a thorough assessment of potential wiring problems or physical damages, as accurate diagnosis relies on completeness in this process. In the fourth step of troubleshooting, it is crucial to check for continuity between the fuel temperature sensor's 2P connector, terminal number 2, and the vehicle's body ground. When measuring, look for continuity. This indicates that there is an uninterrupted electrical path. The relevant wire side at the female terminals for this connection is identified as TF2, green, red. If there is continuity detected in this circuit, it confirms that there are no breaks or disconnections, leading you to repair any short in the wire between the ECM, specifically pin B5, and the fuel temperature sensor. However, if no continuity is found, it will indicate a wiring fault, compelling a shift to a different troubleshooting path. Moving on to the fifth step. If continuity is not established in the previous troubleshooting, it becomes necessary to turn the ignition switch to the lock position again. The next critical action is to replace the fuel temperature sensor if diagnostics have consistently pointed toward its failure. After replacing the sensor, it is essential to ensure that all connectors are reinstalled properly, as loose or corroded connectors can lead to recurring issues or additional trouble codes. Given the sensor's role in engine performance, ensuring it is securely connected and functioning correctly is imperative for restoring normal operation. In the sixth step, turn the ignition switch to the on position, 2, again, to prepare for finalization of the repairs. After ensuring that all components have been correctly reattached, it is vital to reset the PCM with the HDS. This action clears any stored error codes and allows the controller to recalibrate itself based on the new sensor readings. After resetting, perform the PCM idle learn procedure, which is crucial for the vehicle's engine control module to adjust the idle speed settings properly and optimize engine performance. This reset process helps in concluding the troubleshooting effectively, while ensuring that the vehicle will respond accurately to any changes in operating conditions. In the final step, it's essential to check for any pending or confirmed DTCs using the HDS after all repairs have been executed. This final diagnostic check verifies whether DTC P0182 persists in the system, or if other related diagnostic trouble codes have presented themselves. If DTC P0182 is still indicated, It suggests that there may have been poor connections or loose terminals at the fuel temperature sensor or the PCM. Should you find the code absent, troubleshooting is considered complete, signifying that repairs have successfully resolved the initial issues. Always remember to document any findings and repairs for future reference, as thorough records can assist in potential follow-up diagnostics or maintenance. After completing the troubleshooting process for DTC P0182, it is crucial to conduct a final repair verification. Begin by confirming that all connectors and components have been reconnected securely. This ensures the integrity of the repairs. Next, check the voltage readings of the fuel temperature sensor again to ascertain they fall within expected thresholds. Lastly, verify system stability by monitoring the engine's performance over a short period to ensure that no diagnostic trouble codes return. If everything checks out with stable performance, it indicates successful resolution of the initial problem. Accurate verification is necessary for maintaining the vehicle's reliability and ensuring that repairs effectively restored intended functionality. To prevent future occurrences of DTC P0182, implementing a regimen of preventive maintenance is vital. Regularly inspect connections at the fuel temperature sensor and the PCM to ensure that they remain free from corrosion and wear. Establish a habit of monitoring the fuel temperature sensor's performance periodically to catch potential issues early on. Additionally, using high-quality fuel can help maintain the fuel system's integrity and sensor longevity by reducing deposits and contaminants that can lead to sensor failure. Ensuring that the vehicle undergoes regular servicing encompasses these aspects, as thorough preventive maintenance supports the longevity and reliability of all components. In conclusion, DTC P0182 indicates a low-voltage condition within the fuel temperature sensor circuit, directly impacting fuel management and engine performance. Through following systematic troubleshooting steps, including checking data readings, inspecting connections, and potentially replacing the sensor, we can effectively address this issue. Understanding the roles of the fuel temperature sensor and its integration with the engine control module allows for more effective diagnostics. Regular maintenance and inspections can further prevent similar faults in the future. By keeping up with these practices, Honda Civic owners can ensure consistent performance and reliability in their vehicles. Please like and subscribe to the channel. See you next time.